Hi folks, so on the bench we have a Taito Lunar Rescue. As you can see, it looks very similar to the Space Invaders style 3-stack board sets. In fact, the EEPROM board and the CPU board are identical. The difference being the soundboard is slightly different to cater for different sounds. So I have hooked it all up, and as you can see, it's doing absolutely zilch. So the voltages are all okay, they're all going to where they need to be, but doing some initial checks. So we've got 74 161 counters up here. They are quite common for failing on these boards. It's one of the things now I've come to test first, and just going down them on pins 14, 13, 12 and 11, there should be clock signals coming out, and they're like multiples of each other, descending downwards, and I've found that number 7, which is this one here, if I just go on here, that seems to be healthy. So that's 14, 13, 12. But when we get down to 11, there's nothing on there. And because these particular chips, they count and they cascade, so one feeds into the next chip to create all these cascading counters for the entire system. If you get one watt fails, that will then cause issues with the next one. So number 6 has got problems as well, this one here. So I'm looking at the moment that I'm probably going to remove this and put it in my tester, just to give it the once over and see where we go from there. So we've took that 74 161 out at location number 7, and I'm going to put it through the check area. So I've clicked on auto find, and you can see it hasn't found it. So what I normally do is I'll go and find 74 161. If we do a test, as you can see, it's failed on multiple parts. Some bits work alright, but it's definitely faulty, so we'll solder a new one in. So we've replaced the 74 LS161 there, and as you can see, it's still the same. So we knew that component was faulty because we tested it, so at least we know that that's a good one now. And if I check on this pin here, it's still held low. The other ones work. So what I'm going to do in this case is I'm going to pull that pin 11 out and test it, just that pin without it being in the socket, and we'll see what result we get then. So as you can see, I've pulled the pin out, number 11. Interestingly, we now have something on the screen, albeit it's garbage. But if I put the oscilloscope on the pin what's out, you can see that that pin now starts working. So we're going to be looking at what that pin feeds, what it goes to, because it looks like that is holding it low. So we're going to refer over to the schematic. Right then folks, sometimes you end up chasing your tail and you end up going down the wrong path, and sometimes you have to rewind a little. So what I did was I used a spare CPU board just to isolate the issue, because as a rule soundboards on these things don't normally cause too much issues. I've learnt myself, don't take that as gospel because we've got the original Lunar SQ ROM board here. I've put the Lunar SQ CPU board on, and I've just decided to stick my spare Space Invaders soundboard on, and lo and behold, the game is working perfectly. So there's obviously something on the soundboard signal wise which is screwing up the rest of the board. Now I've never had this issue before, so I'm gonna have to start digging. Now the issue is I don't have a schematic for the Lunar SQ soundboard, which is here. I'm hoping most of it is very similar to a Space Invaders, but we will see. So going back to the drawing board, and after some extensive testing and banging my head against the wall, I found a number of issues with this board, albeit didn't fix it totally. So the power on reset circuit wasn't working properly, and that was down to two faulty 74LS161s there. There was countless chips over the board, what initially looked like they'd had factory modifications done on them, but they hadn't. It looked like somebody was trying to find exactly what the problem was with the output on this board, and they were going down a problem with the video signal, which leads me to the fault, the major fault, what has stopped this board from working. Now I'm just going to switch it on at the moment. And we have nothing on the screen, and I was basically messing around with this connector And if I undo the connector slightly on one side, we suddenly get a picture so after getting this connector in a kind of half on and half off state, suddenly we start seeing a working game. Slightly. There's a couple of graphic glitches, but it does seem to be running reasonably well. So as soon as I plug the ribbon cable in properly, the image then just disappears on the screen. And if you analyse anything on the board, basically it's just in some kind of stuck kind of state, really. So all the connections here aren't documented that great. There's nothing in the Taito schematic documentation which gives you a list of the 2x25 pins in these connectors and tells you exactly what they do. You have to literally go through the entire schematic and trace them. So that's what I did, and I basically found a signal which supposed to have had a 960 hertz square wave signal. Now this comes back from these counters which we first started checking, and if you remember on IC number 7 we had one which almost looked like it was being pulled low all the time. Now this 960 hertz square wave also goes all the way through the boards and is actually used on this board to create a signal to be used for the sound circuit. On Space Invaders it's used to generate the Extra Life sound. So I found out that this is on one of the connections at this end of the connector. As soon as I plug this in, it grounds, and it's got a direct link to the ground plane, which basically then halts the 161 up here and causes the entire board to lock up. And what I actually found was the short is actually this chip here, and it's actually internal to the chip. So what I did was I decided to snip the leg what the 960 hertz signal goes to, which is pin 1. Okay, so after cutting that pin, you can see now that the board is working perfectly. So I've got the multimeter on pin 1 and the ground pin on this chip. Pin 1 is now isolated, and as you can see we've got continuity, and that's internal to the chip. So that chip is bye-bye.